Alright guys, welcome to Unit 9. It's Sequence and Series. Today we're going to look at 9.1, which is sequences. Our objective today is that students will be able to identify different sequences. So first of all, what is a sequence? A sequence is also known as an ordered list of numbers, and this is extremely important in math, both theoretical and applied math. Now, a sequence is formally defined as a function that has a domain where the set is from 1 to 3 and goes on to infinity. So, for example, a sequence is defined by the equation a of n is equal to 2n minus 1. The question says find the first three terms of the sequence denoted by a1, a2, and a3. So this is just like we had those f of x is equal to something where you would plug in for x. So think of this as a1 is the same thing as saying find a of 1. So using this function, we're going to plug in wherever I see n, I'm going to plug in 1. So this becomes 2 parentheses 1 minus 1. 2 times 1 is 2. 2 take away 1 is 1. Same goes for a of 2. A of 2 is the same thing as a of 2. 2 parentheses, wherever I see n, I just replace it. This becomes 2 times 2 is 4, minus 1 is 3. A to the third. A3, 2 times 3 minus 1, that is 5. Now looking at this sign, remember this summation sign? You've seen this in Unit 8. So it says evaluate the sum of I given by the summation of I equals 1 to 5, a to the ith, meaning using this here. So all this means I'm going to find the sum of a to the 1 plus a to the 2, a3, a4, a5. I know a to the 1 is 1 plus 3 plus 5 plus, I need to find a to the 4th. So this will be 2 times 4 minus 1, that's 7. And then I got to find 2 times 5 minus 1 is 9. When I add all of that up, I should get the summation as 25. That's it. Now, keep going on. It says a sequence can also be defined by using a recursive definition. When a sequence is defined recursively, terms are found by operation on a previous term. So this is saying the next term in line consists of something previously. So let's see. Look at this example. A sequence is defined by a recursive formula. A subnotation n plus 1 is equal to a to the nth plus 5 with a1 equals negative 2. Generate the first 5 terms. So I already know a1 is equal to negative 2. I want to find a to the second. Now a to the second, if you look at it here, it says n plus 1 means that you're taking the previous, so this is our next term. And here, in order to get that, I have to take the previous term and add 5. So in this case, it will be the previous term, which is negative 2, or let's write it out, a1 plus 5, which is equal to negative 2 plus 5, which is 3. Now it says a to the third. I'm using the previous term, which is a2 plus 5, which is actually 3 plus 5, which is 8. A to the fourth is my previous. I'm going to stop writing. 8 plus 5, which is 13. And then my last one, because I'm finding the fifth term, is the previous, which is 13 plus 5 is 18. So these here are my first 5 terms that I was asked for. It says determine the value of a to the 20th. Hint, think about how many times you have to add 5 to get to negative 2. So a to the 20th, how many times do you have to add 5 to get to negative 2? So it's going to be, what do you think? To find a to the 20th, we must add 5 to negative 2 how many times? 19 times. So it's saying I'm starting with negative 2. How many times do I add 5, add 5, add 5, add 5 in order to get 20? How many times here? That's my question mark. So it's actually 19 times. So then it becomes a to the 20th is going to be negative 2 plus 19 times 5, and this works out to be 93. Now, on the Regents, they like to give you a sequence and say, try to determine what is happening here. So for example, determine the recursive definition. Once they say recursive definition, it means it has to do with something from the previous. So it says, if you look at this, 5, 10, 20, 40, 80, 160, what does it look like? It looks like, of course, you can see that each term is twice the previous. So 5 times 2 is 10, 10 times 2 is 20, and so forth. But because it's a recursive, I have to say that 1 is starting at 5, and then n plus 1, which is whatever term I'm looking at, I'm taking 2 times my a to the nth. So in this case, my a to the first is 5, so then my second term would be 2 times 5, which is 10. My next term would be 10 times 2, which is 20, and so forth. So because of recursive, it means I had to give a specific definition. Now I popped this Regent question. From the recursive definition, define sequence t of n is equal to t to the nth minus 1 squared plus 2. T1 is equal to 2. Find a value of t to the fourth. So how do you find t to the fourth? Let's get some space here. So T1 is 2. T2 is my previous term. My previous term, which is 2 squared plus 2, which is equal to 2 squared is 4 plus 2 is 6. T3 is my previous term, which is 6 squared plus 2. 6 squared is 36 plus 2 is 38. T4 is equal to 38, my previous term, square, plus 2, which gives me, and I'm going to just write it here, 1, 4, 4, 6, which is choice number 4. So let's move it on. It says, one of the most well-known sequences is something called a Fibonacci sequence. You'll learn a lot about this in college, which is defined as a recursive using 2 previous terms. So just now we talk about a recursive using 1 previous term. Now we're going to talk about 2 previous terms. It says a to the nth is equal a to the n plus a to the n minus 1, and a1 is 1 and a2 is also 1. So let's just write that in the side. a1 is 1, a2 is also 1. Now a to the third, and you can write it out. It says it's a to the nth, so that means your previous a2 plus a1. In this case, is going to be 1 plus 1 is 2. A to the fourth, it would be a to the third plus a to the 2. A to the third is 2. A second is 1. This becomes 3. A5 is equal to a to the fourth plus a to the third. Fourth is 3, and a to the third is 2. This is 5. A6 is equal to my 2 previous terms, the sum of my 2 previous terms. 5 plus 3, which is 8. So I have 2, 3, 5, 8. The hardest thing is just to understand what these recursive definitions mean. Find an algebraic formula similar to what we did in exercise 1 for each of the following. Remember, the domain is from 1, 2, 3, and so on. Now look at this. What can you tell me? What do you notice? 4, 5, 6, 7. Something that has to be in common. So 4, we can say is 1 plus 3. 5 is 2 plus 3. 6 is 3 plus 3. 7 is 4 plus 3. Notice they're all adding 3. So I can go ahead and saying it's a to the n is equal to whatever term it is, the first term, the second term, the fourth term, the fifth term, whatever it is, plus 3. So if I want to find the fourth term, I will plug in 4. So this would be my fourth term would be 7, which is correct. 2, 4, 8, 16. What do you notice? This is 2 is actually 2 to the first, 4 is 2 to the second, 8 is 2 to the third, 16 is 2 to the fourth. So they're all base 2 raised to some kind of power. How is this power related to where they are? So this is my first, second, third, fourth. So I can write this as a to the n is equal to 2 to the nth power. You just have to be able to identify the pattern. The last one says each of this term is divided by the n, because this is the same thing as 5 over 1. So notice that each term is 5 is just divided by some number n. So this becomes a to the n, which is equal to 5 over n. That's it. Last example before you go and practice. Which of the following would represent a graph that has a sequence of 2n plus 1? So this is the same thing as if you were graphing in the calculator. This, you can graph this as 2x plus 1. So let me just make a note. Graph on the calculator. If you look at it, a sequence starts at 1. Okay? Always has to start at 1. So I know that n equal 1 can only include if it's a domain of the integer. Hence, the points cannot be connected because it would include all types of real numbers. So, when you graph this, you're going to see that it's going to be a straight line. But remember, when we're dealing with sequence, we don't connect them. Because if I connect it, it also includes this number right here. And that's a decimal. I only want numbers that are from 1, 2, 3, or what you call whole numbers. So the sequence has to start at n equals 1. So let's really quick, remember always sequence start at 1. So a to the 1, what do I get? 2 times 1 plus 1. This is 2 plus 3. So at 1 it's 3. So here at 1 it's no. So bam, there you go. At 1 it's 3, which is my first point. Here it says at 1 it's 1. But at 1 you just substitute your values in. Alrighty. That's it. Very short and simple lesson. Go ahead, try those practice problems and come see me for your quiz. Bye.